This video is about chapter 2 from Maths NCRT class 10. Polynomials. So first let's discuss two concepts. Actually one concept. What a polynomial is. So a polynomial is an algebraic expression. Algebraic expression basically means um, an expression with the variable, like maybe we could say ax square plus bx raised to 1 by 2 plus cx or anything like that plus d. This is an algebraic expression. It contains variables. Now the peculiarity of a polynomial is that the power of the variables, that is, when you write x square, this thing on the top, this is called the power of the variable x. Now the power of the variable, whichever variable it is, it can be t, x, y or anything, the power of that variable should be a non-negative integer. That is, the power can be 0, 1, 2, 3, 4 and so on. But it cannot be things like 1 by 2, negative 1, etc. So, on this same thing, a few questions may be asked. You will be asked, is x square plus x raised to 0.5 a polynomial? It is not, because this is not a non-negative integer. This is not a polynomial. 0.5 is not a non-negative integer. Maybe you will be asked x square plus 1 by x. Now you need to watch out here, because this does not mean that the power of x is 1. Okay, 1 by x means x raised to minus 1. 1 by x means x raised to minus 1. But that is negative. For polynomials, we need non-negative integer as the power of the variable. But this is negative, so this is not a polynomial. If you are given x square plus root of x, this is not a polynomial, because this can be written as x square plus x raised to 1 by 2. This is not a polynomial. So these are some MCQs or 1 mark questions that can be asked for the exam. Another concept is the zero of a polynomial. Now, if you are writing a polynomial, you can write it as p of x equal to whatever the polynomial there is. Let's say the polynomial that we have is let's say that the polynomial that we have is x square minus 5x plus 6. So we can write p of x equal to x square minus 5x plus 6. We need to find the value of x. Okay, we need to find the value of x that would make p of x, or this thing, equal to 0. We need to find the value of x that would make this into 0. This is 2, okay, I do not mean 5, 2. X square minus 5x plus 6. So I know the answer, so I'm just going to write that down. So p of x equals what? The zeros are 2 and 3. If you substitute 2 and 3 into this, you will get 0. More information about this can be found on the video of quadratic equations that is on this channel itself, so you can check that. You can see how exactly I solved this. Now, we now understood what 0 of a polynomial is. Now we need to know the geometric meaning of 0 of a polynomial. So, consider the polynomial ax plus b where a not equal to 0. Okay, let's consider a polynomial ax plus b where a is not equal to 0. Now, if we are graphing this, or we are putting this into a coordinate plane graph, what we need to do is to say y equal to ax plus b. Now you might be confused on a and b. Using a and b might be confusing. You can replace that with 2 and 3 for this example. Okay, let's say that we have this y is equal to 2x plus 3. Just equate. Okay, y is equal to 2x plus 3. What you do is that you take values of x and find the value of y. So let's say you took x is equal to 0. If x equal to 0, that would mean y is equal to 3. So we can plot 0, 3, 0, 3. That is somewhere around here. Let's say. Now you take if x is equal to 1. If x is equal to 1, you will get 2 plus 3. Y is equal to 5. Substitute x as 1. Now let's say this is 1 in the x-axis. This is the x-axis and this is the y-axis. Y is equal to 5 will, let's say, be somewhere around here. Now what you need to do is that if you're drawing a graph, you could connect these points and you can draw the graph of this polynomial. That is the graph of this polynomial. So this is how we represent them in a coordinate plane. This is how we represent them in a coordinate plane. Now this is for polynomials with the maximum degree of x as 1. The maximum power of x in this polynomial is 1. So for the maximum power of the variable, we call it the degree of the polynomial. Okay, degree of the polynomial. So here the degree of the polynomial is 1. Now let's say that the degree of the polynomial is 2. Something like x square minus 5x plus 6. If we want to plot this on the coordinate axis, what do we do? So for this, let's equate them to y and let's have our coordinate planes here. So one thing to note here is that last time I did not draw these arrows because the coordinate plane, it is never ending, it goes on forever. Okay, and you need to draw these symbols also. So this way is y, this is x, this is y dash, and this is x dash. Now the peculiarity of the graph of a polynomial with the degree 2, or simply called the quadratic polynomial, is that its graph will look something like this. Okay, and we call that shape the parabola. Okay. Now for this specific graph, the parabola looks more like this, and we might be asked questions on which way does the parabola open. Is it upward like this or downward like this? So there is a way to find if the parabola opens upward or downward. The way is, check the coefficient of x square. If the coefficient of x square is positive like this is 1. Here the coefficient of x square is 1. Okay, if it is positive, the parabola looks like this. If it is negative like this, the parabola will be like this. Now here's the question, what exactly are the roots? So before I continue, if a is greater than 0, that is if it is positive, the parabola looks like this. If a is less than 0, the parabola looks like this. Okay. Now, what exactly are zeros? So the point where the graph crosses the x-axis, this one, that will be the zero of the polynomial. So for our example of the parabola, there are two places. No, the parabola is wrong. The parabola looks like this. Why? Because the coefficient of x square is positive. Okay, note that. Now here in this case, okay, let's see this again. My mistake, because the points where the parabola crosses the x-axis is 2 and 3 for this specific polynomial. Okay, you don't need to worry about how we got that for now, but then this is how we do it. So the places where it crosses the x-axis, the value of x there is the zero of the polynomial. Now a few things that you need to note is that this is not the endpoint, so it can go on up to infinity. And for the parabola also, these are not the endpoints, it can go up to infinity. Okay, so we understood the graphical representation of zeros of the polynomial, that is, it crosses the x-axis. Now from that, I would like to ask a few questions. Let's say that this is my coordinate plane, y, y dash, x, x dash. This is my coordinate plane. I'm just going to copy it because I'm going to use it a lot of time. How many zeros does this have? Does this polynomial have? So you count the number of times it crosses the x-axis. There is one time. Now don't confuse with this axis. Okay, this is the y-axis. You don't care about y-axis. The point where it crosses the x-axis, there are one such point. Therefore there is 1 0. Okay, what about this? Here again it crosses one time. I'll just redraw this a little better. It crosses one time. Therefore, this also has 1 0. This crosses 3 times. So this has 3 0. Now I'm going to give you two interesting examples. What about this? So as you can see, this doesn't cross the x-axis anywhere. So there are 0 number of zeros. That is, there are no values, no real values. Okay, there are no real values of x that would make the polynomial equal to 0. Another such one is this. This too doesn't cross the x-axis anywhere. So there are no zeros or 0 number of zeros. Okay, that's the concept. Now, the next portion is perhaps the biggest portion of this chapter that we need to know. The relationship between the zeros and the coefficients in a polynomial. So let's consider a polynomial whose degree, we used the term degree before we defined it. So if you forgot, just go back again. Degree of a polynomial is 1. Let's see a polynomial whose degree is 1. So ax plus b, where a not equal to 0. If a equal to 0, then it will simply be b. Okay, there the power of x is equal to 0. Maximum power is 0. That's not what we want. We want a polynomial whose the power of x, maximum power of x, or the degree will be equal to 1. Such are called the linear polynomial. Now here a few things to note is that a and b are real numbers. So this means belongs to real numbers. Here we want to find the relation between the coefficients, these are the coefficients, and the zeros. So to get the zeros in linear, that is the polynomial with the degree equal to 1, to get the zeros here, you just equate it to 0, and you will see that the value of x is minus b, because b goes to the other side, it will become minus, and a go to the other side, it will become divided by. So x equals minus b by a. Okay, this is a simple relation between zeros and coefficients in linear equations. Now the next thing that we are going to cover is quadratic equations. So what are quadratic equations? The degree is 2. Now quadratic equations will be of the form of ax square plus bx plus c. Here a, b and c are the coefficients. Okay. Here the relation between the zeros and the coefficients are, we know that in a quadratic equation there will be maximum 2 zeros, because we saw the parabola can cut in 2 parts. Okay, there are no more zeros than 2. So I'm going to say the zeros are alpha and beta. Now you don't worry about the value of these. We are using x, y, z for variables, right? These alpha and beta are just other variables. They are Greek letters. Okay, so you don't worry about what the meaning of they are. Alpha and beta. Now, the relation between the zeros and the coefficients in quadratic equations is that alpha plus beta, the sum of zeros is equal to minus b by a. In quadratic equations, the sum of zeros is minus b by a. The product of zeros, that is alpha beta, product of zeros are c by a. Product of zeros are c by a. Let's try an example. X square plus 7x plus 10. If you are asked to find the sum of zeros, alpha plus beta will be equal to minus b, that is minus 7 by a, 1, that is minus 7. And if you are asked to find the product of zeros, alpha beta, that will be 10 by 1, which is equal to 10. Okay, now just to make sure that we understood, x square minus 7x plus 10. If this is the case, then alpha plus beta will be equal to minus of minus 7. Why? Because we need minus b, and b is minus 7. So minus of minus 7 by 1. If you have two minuses like this, turn that into a plus. Alpha plus beta will be equal to 7. Alpha beta will be equal to 10 by 1, which is 10. Okay, so we tried that for two quadratic polynomials. We tried this relation. Now, one main type of question that could come is, let's say we have a polynomial x square minus 2x minus 8. We'll be asked to verify the relationship between zeros and coefficients. So in my video about quadratic equations, I have discussed on how to find the zeros of quadratic equations. In the same way, what you have to do to find the zeros of the quadratic polynomials is to equate these to 0, make them into a quadratic equation. Now this is a quadratic equation. You apply the quadratic formula, okay, and then you will get the zeros. Or what you can do is called the method of splitting the middle term. That will be a pretty difficult method, but then with enough practice you will get it. Split the middle term basically means x square, and then you see minus 2x. You need to split them into two numbers, let's say ax and bx, such that a plus b equal to minus 2. Okay, that is a plus b is equal to the middle term. coefficient of the middle term, and a multiplied by b is minus 8. That is the constant. Now, for an example, this could be x square minus 4x plus 2x minus 8. This will be equal to 0. Okay. So, I would still suggest that you cover quadratic equations first and then understand how to apply the quadratic equation and apply it here, because splitting the middle term is a very difficult thing to do, and most of the errors can happen there. I'll do it in two ways so that you can see exactly what to do. So now what you do here is take this as one box, take this as another box. Here x is common, you can take that outside and you'll get x minus 4. Now if you check here, you can take 2 in common and you'll get x minus 4. If you don't understand how I did this, please go over distributive property. If you don't understand, please watch some videos on distributive property. Now this will be equal to 0. Here x minus 4 is common. Take x minus 4 out and you'll get x plus 2. Okay, now this will be equal to 0. Let's say you have two numbers and they multiply, you will get 0. So any one number should be equal to 0, right? If you have two numbers a and b and you multiply and get them as 0, either a should be equal to 0 or b should be equal to 0. If none are equal to 0, then that is wrong. Okay, so either x minus 4 is equal to 0 or x plus 2 is equal to 0. Now this would mean that x is equal to 4 or x is equal to minus 2. So now with this you can change things around here and there. Okay, so alpha we can call it 4 and beta we can call it minus 2. If you substitute 4 and minus 2 to the original polynomial, you will get 0. Now the sum of alpha and beta, they are 2. Okay, similarly minus b by a, that is minus of minus 2 divided by 1, that will be equal to 2. Change this into a plus and then you'll get 2. So this 2 is equal to minus b by a. What is minus b by a? 2. So that will mean alpha plus beta is equal to minus b by a. Alpha beta, that is minus 8, will be equal to c by a. Why? Because we have minus 8 by 1. So that means alpha beta equal to c by a. This is the method of doing this. So you find the zeros and then you will equate them and see if it is minus b by a and c by a. Now the method to do by the quadratic equation is pretty simple. X is equal to minus b plus or minus root b square minus 4ac by 2a. This is the quadratic equation. So you need to know what it is. So please go over the quadratic equation video because that will come very much in handy. It will help you in the exam. I can write that down and sign it if you want to, but then I'm lazy to do that, so I'm not going to do that. So x is equal to 2 plus or minus root of b square, that is 4, minus 4 into square of minus 2 is 4. It's not minus 4. So 4 minus 4 into a is 1 and c is minus 8 by 2a, that will be 2 into 1 or 2. X is equal to 2 plus or minus the root of 4 minus 4 into minus 8. Minus and minus cancel into plus. This will be 32. 4 into 8 is 32. Divided by 2. That will be equal to 2 plus or minus root of 36 by 2, which is equal to 2 plus or minus 6 by 2. Root of 36. Root of 36. The square root of 36, that will be 6. So 2 plus or minus 6 divided by 2. That will be equal to 4, or 2 plus 6 divided by 2, that will be 4, or 2 minus 6 divided by 2, that will be minus 4 by 2 or minus 2. Roots are 4 or minus 2. Sorry. So the zeros of the polynomial are 4 or minus 2. This is exactly what we got here. Quadratic equations would be, quadratic formula would be way more easier to do if you just remember what the quadratic formula is. So I suggest you study both methods, do some more problems here, and then you'll crack it. Now we need to do 2 more different types of this. Let's say you have 12m square minus 3m and you need to verify the relation between zeros and the coefficients. So here 3 is common and m is common. There is m in both. Now 12m square divided by 3m would be 4m. Okay, minus 3m divided by 3m would be equal to minus 1. And this is equal to 0. Don't forget to equate it to 0 and write equal to 0 in every step, or marks will be deducted. Now 3m times 4m minus 1 equal to 0. So either 3m is equal to 0 or 4m minus 1 is equal to 0. So 3m is equal to 0 or 4m minus 1 is equal to 0. Okay, if 3m is equal to 0, that means that m is equal to 0. Okay, 3 goes to the other side, 0 divided by 3 is still 0. So m is equal to 0. Or if 4m minus 1 equal to 0, that would mean that m is equal to 1 by 4. M is equal to 1 by 4. So here alpha is equal to 0, beta is equal to 1 by 4. Okay, alpha plus beta would be 1 by 4. Alpha beta would be 0 multiplied by 1 by 4 or 0. Now minus b by a. What is minus b by a? Minus of minus 3 by 12. Okay, that will be 3 by 12. And you can simplify this fraction into 1 by 4. Why? You can take 3 from both sides, right? 3. Divide 3 on the numerator and the denominator and you will get 1 by 4. So minus b by a is 1 by 4 and c by a. So c is 0 here because there is no term for c. That will be 0 by a. A is 12, which is equal to 0. So alpha plus beta will be equal to minus b by a and alpha beta will be equal to c by a, like our above example. Okay. Now there's just one more type Okay, this is one more type, and that type is something like 3x minus 16. Here b is equal to 0. Okay, sorry, 3x square minus 16. So the first thing that you would want to do is write this as root 3x plus root 16 into root 3x minus root 16. Write it like this and then equate them to 0. Don't forget to equate them to 0. Write them like this, okay. And then root 3x, you know root 16 is 4. So you write 4 here. Root 3x minus 4. See, minus and then 16. Root of 16 is 4. This will be equal to 0. So either root 3x plus 4 is equal to 0 or root 3x minus 4 is equal to 0. Just like before, it's nothing. So that means x is equal to minus 4 by root 3, and this means that x is equal to 4 by root 3. Alpha will be equal to minus 4 by root 3 and beta will be equal to 4 by root 3. Alpha plus beta is equal to 0 and b here is equal to 0. So b divided by 3 will be equal to 0. Minus b by a will be equal to 0. Alpha beta would be minus 4 by root 3 into 4 by root 3, which equals minus 16 by 3. Minus 16 by 3. C by A will be minus 16 by 3. So what this means is alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. That is verified. So writing it like this will help you a lot. And you can just multiply these two and see if these are 3x square minus 16. If this will multiply and get you this, you can check that if you do not believe that your answer is correct. Alright. Another important thing that I have noticed a lot of people missing is that 2 equals root 2 into root 2. 3 equals root 3 into root 3. Okay, so don't miss this, because some questions like root 2x square plus 2x may look difficult, but then you can take root 2 in common and x in common. This will be simply x and this will be root 2. It's that simple to solve. So please just analyze all the problems that I did, and then you will understand how to solve if such questions are asked. Another note to observe here: if we are given alpha and beta, the zeros of the polynomial, if we are given those, then the polynomial would be x square minus, now in bracket, alpha plus beta x plus alpha beta. So question might come like, if alpha is equal to 1 by 4 and beta is equal to 1, find the polynomial. So what you do? You do x square minus alpha plus beta x plus alpha beta, x square minus 1 plus 1 by 4 x plus alpha beta, x square is equal x square minus 1 plus 1 by 4, that will be 5 by 4. You can check. X plus alpha beta 1 into 1 by 4, that will be 1 by 4. So x square is equal to 5 by 4x plus 1 by 4. Now don't write equal to 0. Okay, this we are asked to find the polynomial, so do not equal to 0. Now it is completely fine if you leave it like this. Okay, so it's completely fine if you leave it like this, but then there will be some issues because sometimes teachers might want us to not have this by 4 as the denominator. That's okay, because just find the LCM of the denominators. Okay, 4 and 4, LCM of 4 and 4 is basically, we know that it is equal to 4. If you don't, that's fine. You can check the first chapter's one short video and you will understand. What you do is that you multiply this entire polynomial by 4. This will be equal to 4x square minus 4 into 5 by 4x plus 4 into 1 by 4. Okay, so now this will be equal to 5x square. 4 and 4 will get cancelled. Minus 5x and 4 and 4 will be cancelled. Now plus 1. This may be your final answer. Write this as your final answer. I mean, of course, this is good enough. This is correct. This is correct. So, if you are writing factually, this is absolutely fine. But then, to get rid of the denominators, multiply by 4. Okay, that's all. Now, before we stop this video, there are some more type of questions, but then I think we can figure that on our own. I need to discuss a few simple points, that is, laws of exponents says, if you have alpha and you have beta, okay, alpha raised to m, any m, multiplied by alpha raised to n, this will be alpha raised to m plus n. Okay, alpha raised to m divided by alpha raised to n would be equal to alpha raised to m minus n. Okay, alpha raised to minus m would be equal to 1 by alpha raised to m. Yeah, and this is one more that is not related to the laws of exponents, but it is pretty important to solve the rest of the type of questions that may come. That is, if you are given alpha square plus beta square, this will be alpha plus beta the whole square minus 2 alpha beta. These are some that will help you solve lots of problems that may come. But then we discuss the absolutely sure questions that could come for the exam just before.